Shocking. Impossible. Real. NASA has officially admitted that the interstellar object 3I Atlas might be bending solar winds with its own magnetic field. For years, science told us only massive planets could pull off such a cosmic shield. But now, something the size of a fragment has shattered that rule. Was this a glitch in the instruments, a new force of nature, or something far stranger? In this video, we dive into the evidence, the panic, and the unanswered questions surrounding 3I Atlas. Because once you see the patterns, you'll never look at the solar system the same way again. The impossible announcement. When NASA makes an announcement, the world usually braces for dense technical jargon or cautiously worded updates. But on April 17, 2024, a single line in their release sent shockwaves far the scientific community. The statement read, "Unusual magnetic features detected in the vicinity of 3I Atlas. Further analysis ongoing. Clinical, reserved, and almost sterile in its delivery." Yet those few words carried an earthquake of meaning. Because in plain English, NASA was admitting that a comet-sized interstellar object might be bending the solar wind, something no fragment of rock and ice should ever be capable of doing. The timing was crucial. Within minutes of the release, journalists, astronomers, and even late-night hosts seized on two phrases that rarely make primetime headlines: magnetic field and solar wind. Normally, these terms belonged to specialists buried in plasma physics papers. Suddenly, they were everywhere, ricocheting across news tickers and social feeds. And for good reason. What NASA hinted at wasn't a minor curiosity, it was a direct challenge to one of space science's bedrock rules. Only massive planets with molten cores, spinning fast enough to act as dynamos, were thought to carve out a shield against the Sun's relentless stream of charged particles. Earth, Jupiter, Saturn, these giants could stand their ground. But a body only a few miles wide? Impossible. Within NASA's own ranks, the disbelief was almost palpable. Dr. Richard Kowalski, whose team first flagged the anomaly, typed out a message that would reverberate throughout the worldwide astronomy community. "Anyone seeing this in the mirrored logs? This shouldn't be possible for a body this small." There was in this sentence the crack of a lifetime's worth of certainty. It was one thing to bend solar wind, it would be entirely another violation of physics in itself. As the data confirmations rolled in, the tension became almost tangible. Veteran aliophysicist Dr. Christina Cohen, who had worked with the Parker Solar Probe, recorded in her laboratory journal that Atlas had a magnetic signature like some minor planet, not a comet. Unusual, to say the least, not just weird, but unprecedented. Suddenly, the floodgates opened as data requests poured into her inbox from colleagues and government offices alike, all clamoring for raw data, calibration files, and error checks. Could it actually be real? Any chance at all that the reading could have been fabricated, caused by a bug, or just a good old magnetometer glitch? Skepticism ruled for 48 hours. Backup instruments were fired up at a number of ground stations. Data were mirrored, reprobed, and reanalyzed. Little by little, doubt began to fade away. This was not going away, the anomaly was stubbornly reproducible. The chances of one of the instruments being out of order dropped to near zero. All of the logs were lined with Atlas's path across the ecliptic. This had caught the attention of NASA. This cannot be considered an outlier. This is evidence that poses ugly questions about how little we really know. Its cultural impact was instantaneous. Comet with a force field had electrified the tabloids. Talk radio was torn apart by speculation over alien technology. Meanwhile, an honest effort by the science community at damage control was being attempted by trying to inject a little caution into this frenzy. By this time, damage rather inspiration had done its job. For the first time in decades, solar wind and magnetic fields made it to the front pages, and it wasn't just a problem in astronomy. Rather, this was a story placed right at the heart of our cosmic rulebook. And that's exactly when 3 spacecraft, scattered millions of miles apart, recorded something that changed the debate forever. 3 probes, 1 anomaly. The scientific world thrives on evidence, not headlines. One press release might shake the public, but among researchers, data is king. And that's exactly what arrived on August 18, 2024, at precisely 8:03 Universal Time Coordinated. 3 separate spacecraft, positioned in vastly different corners of the solar system, each caught something extraordinary in their instruments. On their own, any one of these readings might have been dismissed as background noise or a glitch. But taken together, they told a story too precise to ignore. First came SOHO, the solar and heliospheric observatory stationed at the L1 Lagrange point between Earth and the Sun. Its plasma sensors detected a bow-shaped disturbance in the solar wind, a ripple that shouldn't have been there. Normally, such a disturbance only appears downstream of planets with strong magnetic fields, like Earth or Jupiter. Yet this one was perfectly aligned with the trajectory of a tiny, interstellar body, 3I Atlas. The timestamp was locked, 8:03 Universal Time Coordinated. It was a qualified probe 2 minutes later. Very different from the earlier probe was the NASA Parker Solar Probe, which effectively deep into the Sun's corona, measuring a sudden increase in local magnetic field strength. Not a tiny variation but a spike, a clean signal, standing out from the usual solar readings clutter. Parker's magnetometer outlined a gradient shift right across the predicted flight path of Atlas. Time, 8:05 Universal Time Coordinated. Then came a deflection event roughly 6 minutes after the SOHO readings, with other third evidence being contributed by MAVEN, now in orbit around Mars. Its high-energy detectors registered a deflection event, solar particles shifting their path in a manner which were nominally unrelated to the solar output or the weak magnetic influence exerted by Mars. The coordinates yet again pointed back to the Atlas. Now, it was 8:11 Universal Time Coordinated. 3 spacecraft, 3 vantage points, 1 aberration. Almost no chances exist for such a coincidence. Different instruments, made by different teams, millions of miles apart, all recorded the inflow of some phenomena within minutes of each other. Upon checking the mirrored logs, the data matched with eerie precision. Or simply, Dr. Richard Kowalski told his team, "This isn't a glitch." The Aerophysics division of NASA wasted no time. On an emergency call, mission leads from SOHO, Parker, and MAVEN, alongside JPL's Chief of Data Science, dialed in. The agenda was simple: to find out whether or not this was real. By 9:15 a.m., the assembled parties had arrived at a sobering consensus. There was no solar flare, no coronal mass ejection, and no background interference implicated in this event. This disturbance was physically associated with the path of Atlas, a Level 1 anomaly in NASA speak, that is, reserved for discoveries that clash with existing models. The action was taken within minutes and classified. After 90 minutes, a report was drafted with an overlay of readings to be sent to the White House for approval. The technical justification, meanwhile, painted a different picture: SOHO's plasma bow, Parker's magnetic spike, MAVEN's particle deflection, all right in their synergy directing towards Atlas. No solar storm, no planetary interference, just a comet-sized object and a solar wind bending in hitherto unrecorded fashion. Because when rules collapse, explanations rush in and not all of them agree on what Atlas